What is my purpose? You hold my camera. Oh. Something else passes the buck. No Rick and Morty? No.
Yeah, the pie maker.
Oh yeah, David Cross. What, Adventure Time?
Yeah.
Okay. All right. That's funny. So in section 2.7, there were a couple things left over. Let me first remind us, or you guys remind me. There's a question on this test that's going to be on every single test after this also. And someday I'm going to get everybody to get it right, even though you know the answer going in. And that is, what does the z-score tell you? And then even more fundamentally than that is there's a bonus question about what's the standard deviation tell you using aspects of the formula itself, right? To do to make you stay on. Oh my gosh. So first off, let's start with, what's the z-score tell you?
Number of standard deviations. No. How many standard deviations is away from the mean?
Beautiful. So for a data point, it's the number of standard deviations from the mean to that data point. I like it. So if you have a test grade that your z-score is 2.18, are you happy or sad? Sad. I guess it depends on what your goal was, but why should you be happy? Yeah, it's positive, so it's above the mean. And in this case, higher is better, right? Taking a test, unfortunately, sorry for some of you guys, it's not like golf, right? Higher is better. So a z-score is not, a positive z-score is not always better. Golf, it would suck to have a positive z-score. If you don't golf, I'm with you, I don't golf either, but we know that the score lower is better, right? Z-score tells you the number of standard deviations from the mean to the data point. I'm allowed to use symbols. You better put the words in there. Double standard. Oh, well, too bad. Standard deviation. What's the hell's the standard deviation then? If that's built off of standard deviation. The hell. So here's the formula. Here's what I meant by that extra credit. If you haven't taken the test yet, don't worry. You're going to get different questions. Yeah, there's mute. So I can't remember. I think maybe one person got some points on this one. I didn't want you just to read me the formula in English. That's not very explanatory.
Well, this one is sigma. Sigma.
No. What's the idea behind it? What does it mean when you add stuff up and divide by how many there are? What does that process give you? Average, always. If you add stuff up and then divide how many of them there are, that is the average that. So this process gives me the average distance from the mean. Why did I have to square it?
In case there are negatives.
Kill the negatives and then I square root it. So you can basically say the square and the square root are gone and you're taking an average distance from the mean, which is what I want the standard deviation to mean. I want the standard deviation to be, on average, how far away the data points get. And then the z-score uses those as like inches or feet or centimeters. It uses those like units of measurement. So when I say my z-score is 3, I am 3 standard deviations away. My unit of measurement is based on how big my whole data set is. Okay, maybe. So I'm talking about the distance between stars. Would I use centimeters? Only if I was some evil astronomy conversion quiz or something, right? Some of you guys maybe have had those, chemistry even. I'd use light years, maybe, right? That'd be much better. All right, maybe. So my standard deviation then would be huge because I got a lot to cover if I'm talking about distance between people sitting in this room. Now I could use feet, maybe even inches. So now my standard deviation is much smaller because my data is much more clustered together. Okay, let me stop there for a second. All right, so that's why these two things make sense. I want to start with reminding you about what these two things are, because then it makes more sense, these theorems we're about to talk about. There's one theorem called Chebyshev's theorem, and I might call it Chubby Dude's theorem just because And I don't even know if he was a chubby dude or not, to be honest. But it just sounds like it's chubby dude. Here's the idea behind Chebyshev's theorem. And I use this a couple different places. Let's say we go down to Florida. And this is Florida in like an alternate dimension, right? So Florida is made up of only young people. So I go down to Florida and I ask everybody, each person, what's your age? What's your age? Just because I got nothing to do. So I get a bunch of young people and a bunch of old people. Older. And only live for a while. Where's the average age? Somewhere in the middle, so like right here maybe. Let's say that's the average age of these people in this alternate timeline Florida. Right, it's some weird... Did I just do this? I didn't talk about this yet in here, have I? Okay, good. All right. I did it in some workshop a while back. Some weird Logan's Run thing where they kill everybody in the middle of the ages. Logan's Run? Yes? Okay. So here's what's kind of weird. What Chubby Dude figured out was if I go out one standard deviation in both directions, so I go down one and up one. So if I wrote those, are you guys cool with what those mean? What's that 0 mean? Yeah, because, and what do these numbers represent? They are what? Good, so what are they? Z-scores, thank you. Z-score is the number of standard deviations away from the mean. So that's why the mean is 0, because how far away from the mean is the mean? 0, right? You guys with me? It didn't go soul walking, right? It didn't leave itself. It's right there on top of itself. If I go out one standard deviation, maybe I catch nobody. Maybe there's 0% of the data in there. Let me stop right there, because can you imagine, I could have a data set with a lot of small numbers and a lot of big numbers, and there's like nothing in the middle. So we can kind of imagine that, can't you? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 8,000, 8,000, 8,000, 8,000, 8,000. So maybe a standard deviation is not big enough to get all the way out to all the data. Let me let that sink in. Now, if I take one more step out, now obviously from the way I've drawn this picture, I'm going to catch information. But what's neat is, this is true no matter what, I catch a certain amount of information. So Chebyshev's theorem says this: 1, within one standard deviation, within one step of the mean, there's at least 0% of the data. And it's like, whoa, dude, way to go out on a limb. Right? I'm going to guess there's at least none. How many people in the next room? Take a guess. There's at least nobody. Wow, Jeff, you're amazing. No, you're wrong. There's a negative person. No. Too bad. So that's kind of lame. It's like, thank God he didn't stop here, or else, he would have never gotten his name on anything. The second thing he says, if I go one more step out, I must catch at least 75% of the data. And I know you guys right now are like, these are numbers and bullshit, but I want you to understand. You sit down, you write any list of numbers you want to. Just imagine any list of numbers you want, any list you can imagine. Calculate the mean and the standard deviation, go 2 steps out, you're going to catch at least 75% of the data. I don't care what numbers you make. Does that sink in a little bit? Because, and I know right now you're all like, why the hell do I give a shit what percentage of the data is within there? Because we're going to see later that how many airplane tickets they sell to maximize the number of people on their planes depends on this kind of idea, right? How tall we make that door, how often we change filters in hotel rooms, air filters, and so forth. Holy shit, they all depend on this idea. All right, cool, I like it. So within 2 standard deviations, there's at least 75%. And then if you go one more step out, within 3, blah, 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 gather, sorry, 89%, at least 89% of the data. 88.888, but it's 89, that's correct. Now, a real quick, I certainly can't get into the specifics about why it's 75 and why it's 89 and so forth, but if I was some form of God, and I reached down and I made all these people younger. I'm God, and I'm like, screw you, Chevy Chef. I'm freaking God. I'm gonna prove you wrong. All you people get younger, and all you people get older. You know, like the Indiana Jones. You chose poorly, right? What is God trying to do there? Or whoever your favorite deity is, right? What is he trying to do? He wants everything to be wrong. He wants to pull it so that when I go 2 steps out, I don't catch 75% of the data. He wants to maybe make it 0. But the minute he does this, what changes? Standard deviation gets bigger, so I can't escape. Right? Not even an all-powerful deity. Too bad. Whatever your favorite all-powerful deity is. All right. You got trading cards? No? Alright. Alright, how do you guys, we're not going to get into the specifics of these numbers, but, because there's a lot of math behind this. It's not immediately obvious, but at least you can see why it sort of makes sense that I can't escape to some degree. Okay. Now, building off of this, there's the idea of empirical rule. Shit. Empirical rule only works for normal distributions. And what was normal again? Symmetric. Bell curve, much better. Symmetric could be round, 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 round. As long as it folds, but it's got to be like a bell curve. Start low, go high, go low. All those kind of things reference something normal. I like it. I like it. This works for anything. Any set of numbers you make up or that exist anywhere in the universe follows this rule. That's insanity. I like it. So before I get into empirical rule, let me give you a concrete thing about Chevy Chef. The mean for the test. Some of you guys are like, shut up about the test. But the mean for the test was, let me make it a mu, because let's say that's everybody. It's not a sample. Where'd you go, test? 76.8. And the standard deviation was 16.7. So between what 2 data points would you find 75% of the test grades? For sure, at least 75%. How far out you got to go? How far out you got to go? How many steps?
2 steps.
2 steps to catch at least 75%. Do you see that? All right. So if I start in the middle, start at the mean, which is 76.8, and I go 1, 2 steps. Well, 1 step up would be what? Plus this. There it is, 93.5. You guys with me? And one more, right? 16. Add 17 to this, that's 93. Right? And now one more step up.
110.2.
Yeah, 110.2. And then if you go 1 step down and another step down, 1 step down would be 60.1. I like it. 1 more step down.
43.4.
Sweet. So between what 2 grades would I definitely find at least 75% of the data?
43.4.
Exactly, I like it. And that's true. I could show you all the grades. There are some below this, but in between these 2, there must be at least 75%. Which is a real good thing to know. Well, I think this many people are going to show up tomorrow. Here's the average of who's shown up before for this kind of thing. How many chairs are we going to need at most? That's a quick, rough estimate. Do you see what I'm saying? And to cover your ass, you throw some more chairs on top of that. But you don't have to put out there 300 freaking chairs, because you're going to expect at most around 110.2 maybe. Do you guys see what I'm saying? The immediate usefulness of this kind of thing? If I know the mean and the standard deviation, I can immediately do useful shit with it. It's amazing. It's amazing. Okay, maybe. Okay. So tell me this. If that's true, so how much is in here again?
75%.
All right. See if somebody comes through. They're trying to take over our classroom. We have to fight back. Sorry, say it again. Sorry. Just at least 75% elected. Cool. If I go one more step up and one more step down, then I would catch at least 89% elected. Cool. All right. Let me stop there for a second. So empirical rule can just be a lot more specific. This has to work no matter what the hell the thing looks like. It can look like that, the Agents in Florida thing. It can look like anything. It can look like a box. It can look like this. And then this is still going to be true. That's why it's kind of vague, because it's got to cover so many freaking different types of distributions. So give Chubby Dude a break. He did pretty good. Empirical rule, it's got to look like this. It's got to be normal. So I know if I take one step out, it ain't going to be no 0% that I catch. Right? Cool. Ain't going to be no, Jeff. That's pretty good. Reinforce that grammar. Get it? One. So here's what empirical rule says. Within one standard deviation of the mean, if I know it's normally distributed, there must be 68% of the data. Now, if you think about it, that makes sense. It's saying that a little more than half of the data is in that highest bumped area. That makes sense. There should be the most of the data there. If you had to guess how tall somebody was going to be when they came, some dude was going to be, you knew that the average height was 5'9", you would guess 5'9", or somewhere around 5'9". Unless you're gambling, you might go, no, 7'1", come on, 7'1", come on, he's got good returns. Oh, it's a short man. All right. Are you guys understanding? If you had to guess, you would guess somewhere close to the average height, because most men, 68% of men, are within one step away from the average height. If you go 2 steps out, again, just remind me, what are these numbers? Z-scores. I love it. Numbers of standard deviations away from the mean, or more succinctly, that's a hard word to say. Succinctly, it's Z-score. 68% within one. If you go out one more step, 95% within 2. If you go out one more step, it sounds like an old soap commercial. Where are my old people? Fellow old people. You catch 99.7%. Was it 99 and 4400% pure Dove? Or was that Ivory? I forget which soap it was, Stuart. You're like, shut up about soap, man.
So it's 68, 95, 99.7.
Yes, this is the one that you must memorize. This one I don't care about too much.
Is it at least or
No.
exactly 9?
Yeah, it's exactly, to be honest, these are rounded. This is actually 68.28, I think. But we rounded it to 68. But it's not, Chubby Dude says there could be all of it within 2 steps. You can catch all the data in 2 steps, according to this. This one is going to be exactly 68.28, but we rounded it here. Is that cool? Same thing with 95. And then this one, we just made it, we didn't want to round to 100 because that's lying. So we made it 99.7. So again, if you think about heights, how many people, let me give you some specific numbers for the heights. The average height for men in the United States